My mind is exploding with all the moonshot ideas that are pouring out of my soul. I am working on my agentic
because I realized
AI.
there were a couple other things I wanted to talk about. So I wrote up some notes, and to continue on the train of thought of the brain and how the human brain works, I wrote up a lot of, I talked to, Gemini chat, but I talked to Claude Code. So Claude Code is good at coding, but it's also good at chatting with it if you don't mind using the terminal window. And this is one thing with my latest UI project that I'm trying to accomplish, is, among many other just incredible things if I can get them done, and is to get away from this Mac terminal window type communication that I have to talk to Claude Code. So I want something that's really user-friendly and really looks good and has orange, purpley, whatever background, and just is something inviting to do your chatting. And also has fonts that people like me with glasses and had eye surgery, not for cataracts, for a different issue, need bigger fonts and different type fonts, and some people can pick out, this is the pattern matching part of the whole system. So before I get back into the human brain and parts that I want to cover, pattern matching is basically what AI does. So it does it very fast, very efficiently, and it's getting in to be able to do some thinking, but the thinking is all based on pattern matching, and it isn't based on so much the human brain in that aspect. The human brain has two parts. Well, it has the left hemisphere and the right hemisphere. But if you get past that, that's the visualization side, I think, on the right. And I could be wrong, but I'm close enough. And then on the left is the thinking, where you hear that voice inside your head part of the brain. But with AI, you really don't get into that part of the human brain. What you get into is the neural nets, and you get into the pattern matching side. So our brains are set up like this. We have a short-term memory and a long-term memory. A short-term memory in AI is also called the working memory. And then you have the long-term memory, just like in a human brain. These brains are already trained and locked in. So in OpenClaw, the long-term memory that I can change is just basically a regular, file system that's on a file on the hard drive called an MD file, and it's called memory.md, and that holds the truths. That's a different thing to talk about with the OpenClaw. Now, all these things you say I'm saying are part of OpenClaw, and people think, like myself, that these are all part of OpenClaw. Now, all these things, roles, personalities, truths, instructions, these are all not part of OpenClaw. They're part of the models. So keep that separate. The only thing that's part of OpenClaw and things like Olama is a wrapper that controls the memory and how the the models can go in and out of memory, and how it does the memory swapping, so it keeps the right models in memory and everything else. So it's the wrapper around the whole thing. But all these things you hear about that you think is part of OpenClaw is not part of OpenClaw, is part of the models themselves. So I'm using the Gemma 4 model that's based on the DeepMind project of Google. And it has all the coding and the training of the DeepMind system, which is incredible. But it's compacted down to these things called tokens. And a token, it breaks it into English words. And for each letter and each word takes up a certain amount of tokens. How many tokens are in each word, I'm not sure. But basically that's how it works. And the tokens then have a limited number. So to fit on my M1 Max with 32 gigabyte of memory, which sounds big, but really isn't anymore, is that it has to, one, compress it down. So the old idea of compression, like compression algorithms into a backup of your hard drive and your OS, or compression of your video files or your picture files to make them a third of the size of the original and to save space, but still retain most of the code that's needed to reproduce the image again. So they just throw out the bits and bytes. I've learned way back in the 80s and 90s, I learned way back that compression just takes out all the, it's like a sentence, and you're throwing out all the ands, ors, and buts out of your sentence. But the sentence structure is still there. So you can reproduce it. You could even reproduce back into the ands, ors, and buts into a sentence. But then the sentence, instead of being this long, becomes this long when you take all the superfluous structure out of it that's not needed to understand what it is. So I can talk to you and just use the bigger words and the adjectives and adverbs, etc., and taking out the I's, ors, buts, all the little things, and you would still basically understand what I'm talking about. Now that's how compression basically works, at least the old way of compression. So that's what happens with like the big models and what they talk about when they're talking about compressing them down, and the tokens. Now, in a big model, that's why they talk about in billions, 26 billion tokens. But out of that 26 billion tokens, it can only use something around 3 billion at any one given time. So that's your working structure, or your working model is the 3 billion. You have 26 billion to choose from, but you only have 3 billion to actually use. So you've got to decide what parts of the model, because this is the one I'm using, it's called MOB, so multi-models. So it has multi-models, I think 6 or 8, built into the Gemma 4 full model. So it's broken down into 6 individual models before in that, and each one can do a certain thing. One can be a theorist, one can be an architect, one can be, a coder, or you can combine the two. As I was saying earlier, Claude Code and wrote up, if I can figure a way to put on my website or a place for you guys to download. It would be great for you to take all the files I had Gemini, or not Gemini, but Claude Code, write in a Word document in Pages for the Mac. That it's really a nice format to read, and it gives you tons of information that I'm not going to be able to cover here unless I want to go into a 6-hour video. So I'm going to leave that, and some of that I may not know 100% in order to explain it here. I'm going to explain what I know pretty close to 100%. So when we get, so the models are, so you're breaking it down. So what happens is you've got to understand this, and then I can get to how the human brain works. So the tokens, if you only have, making it very simple, let's say I only have 10 tokens. In 10 tokens, I can ask 2 questions, and then the model just airs out. You can say disintegrates or airs out into an error message. Say, I can't go any further, and you only ask 2 questions. So think about that on how I had to deal with, and you'll find out, hopefully if I remember to cover it in this video, you'll find out how I dealt with that process of only being able to. That was one of the early on things I had to deal with. I had to deal with the model itself, the working memory, filling up to a capacity to where it filled all the way up, and then it just went into an, I'm circling like an endless loop. So it would just go into an endless loop, and I don't know, from my point of view, watching the screen, I didn't know what in the heck was going on until I found out through asking Claude Code and Gemini CLI, which also works as a coder, different than the chat Gemini and chat Claude. So I asked them, and over a couple of days trying to figure this out, we came to the conclusion that it was just filling up the short-term memory that, let's say it's only this big. The full long-term memory is like this, but the long-term memory for me is just a file on a hard drive. It's already locked down what the memory is in the model itself. So you got to get your mind around that. So take a break. Drink a swig of your favorite beverage. I've got coffee and water. And think about that for a second. You got to think about all these things step by step. Pause it, rewind it, watch it again. Because this is very important on if you really want to understand how these models and this OpenClaw and everything works. You're really gonna have to focus on what I say and read the documents that Claude Code wrote. When I watch my channel and the parts underneath my video, comments underneath my video, when I figure out how I can upload these documents into there, so then you can then download them. And they're a really good read. It's gonna either really answer questions for you, or it's going to make your mind explode into more and more questions, which you'll have to ask Claude Code or Gemini. That'll make you expand your knowledge and think. So what happened is, so there I had to figure out, okay, it's exploding pretty much and melting down after 3 sentences or 3 comments I make to it, to the AI. And it's just locking up. It's just going into an endless loop. I call it crashing, but it's not really crashing out to the OS. It's just locking up into a loop, an never-ending loop, using full CPU power on my Mac and heating up until my hand was hurting. It was too hot to hold it from underneath. And it was just sitting there. And it was like, this ain't gonna work for me. It just ain't gonna work. And so there's gotta be a way around this. And OpenClaw at the time is trying to, not only does it memory manage OpenClaw, but OpenClaw is trying to incorporate what I'm doing with Claude Code. I'm doing separately. So then I basically, all around this, and then I'll go into detail, but basically I went with Claude Code. I'm doing exactly what OpenClaw is trying to do, but I think my way of doing it over the last month and a half was more intense and fixing the actual problems faster than OpenClaw. So I think OpenClaw fixed maybe one or two of these things. I've just massively redone the whole thing until I think my system isn't error-proof, but is very, getting very stable. And I'm very happy with it. Where right now, I have, listen to this, my project, I have which has now thinking ability and coding ability among its basic role. So my architect has the architect role, but of design and everything around product design and app design. And it also has thinking abilities like reasoning and theory type reasoning. And it also has coding abilities. So even if it doesn't, quote, code, write the actual code, it has that ability to think. You've got to think. You see, this is the brilliant thing that I think I'm thinking in a line of thought that you'll say, oh, that makes sense, that I didn't even think about when you're watching this video. And see if I'm right. See, I'm thinking that if it's thinking on a project and it needs a reason on a project, and then it can think about how you're going to code it in the theory realm. How is theory going to constitute into my project code? Now take a second, and we'll pause. Take a second to think about what that actually means and how that can be very, beneficial when you think along those lines and you combine the modules together, not just using one role. That's what I started with. I started with one role in a company, like being the CIO or being the architect. And then I decided, well, theory was my other agent, the theorist. Theory was just so great to have a conversation with about space and time and other stuff. And I wondered why these other agents just didn't have it, didn't have that something extra. And I didn't know how to explain that something extra. But theory had it. Theory got it. And I kept asking Claude Code, I don't understand what that click is. I don't understand what that something that makes it feel more human, that makes it feel, because I'm not making just cron jobs and skills, and bots that go out and ask it, well, go out and tonight and see what you can create in a little fun game for me. I'm not doing that. What I'm trying to do is make the big picture thing, which is amazing if I get it done, but it's gonna be just an incredible thing if I get it done. It's blowing my mind as I even talk about it with you guys, is that I'm making cyber humans, cyber employees that act, speak, personality-wise, just like a human employee. Therefore, you got to think, okay, I'm scared that these AIs are blah, 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 etc. Stop. You've got to think, as I said before in my chat, you've got to think that it's nothing more than dealing, if you're a manager, managers of a company watching this video, you will understand what I'm saying. My brother started to understand what I was saying because he is a manager. He's a CEO of a company. So he understood that. He brought up the questions, well, what about, somebody can talk about you behind your back and do this and that and screw with your company and leak documents to the internet. Well, humans do that already. So these AIs are no better, no worse than a human. They do things, pattern matching, this much faster than a human. Out of the picture realm, faster than a human. The humans can do pattern matching about this fast. AI can do pattern matching this fast. But other than that, AIs are no different than, think of them as no different than a human employee. So what human employees, we have to figure out how to keep them from clicking on the wrong email. They're clicking on the wrong internet search and leaking all their personal data or the personal company data to some bad guy on the internet. That's no different. So don't be quite as scared as people are about AI. AI has a lot of great benefits, amazing benefits, through trying to find out how space in outer space works, to find out how curing cancers and you name it. Just take a second to think about what would you like to do if all you had to do, you didn't have to do all the clerical work of your company, and you could just sit back and dream the big dreams and think of the big possibilities and sit there, and your role in the company was just that, just to dream the big dreams, and then go back and discuss it with your theorist AIs and your Vicky the physics AIs, and do your physics of your wind tunnel, which is another app I'm going to build, is a wind tunnel app that will allow my model that I build to be able to sit in a wind tunnel and to be able to do all the stuff before I ever build in real life on my 3D printers the model. And I won't have to go out and build this big warehouse and have a big fan and everything of a wind tunnel. If I want to do that as the last stage of my design of a product, I can do that. But think about race cars. Think about building the next Formula One race car. They don't do it anymore in the real world. They build 99% of the race car, they build in a simulation. And then they put it on the track for 3 or 4 days, and they get track time, and they see if it works. But 99% of a race car is built in simulations. So that's what I want to build. Once I get this UI built, I want to go back and build a simulation of a wind tunnel where I can have Vicky and I can have, I think it's Bishop for mechatronics, which is mechatronics or megatronics is electronics theory and mechanical, like building buildings theory, and having them all intermixed, both of those theories as one AI called mechatronics or megatronics, however you pronounce it. And it's all one. So it can do electronics, the resistors, capacitors, your Arduinos and everything. It can do those. And then it can do all the building, the concrete, and how a building structure works, the mechanical engineering. And then Vicky is my physics engineering and how that is going to work and how the air pressure around your model, how is that going to affect? And if I go into outer space with no air pressure, can my model that works within the Earth's gravity and air pressure work in outer space? Or how would I have to redesign it so it can work in outer space? How does, if I want to take a big, huge picture item of, we hear about all these UFOs. So if I take a circular disc UFO, how is that works in outer space? And how is being a circular UFO opposed to being one of those oblong UFOs or a triangle UFO? How does that physics work? And all that I'm going to be able to talk to my AIs about. So let's pause and think about that for a second. And then I'm going to get a drink and then come back to the brain. Okay, I'm back. So the brain. So we're back to, let's refresh our memory. We are back to the conscious mind and the subconscious mind of a human brain, the short-term versus long-term memory of the human brain. So the subconscious mind is the mind where you can drive, you can even drive home, and the last one of the examples in my papers from Claude Code is you can drive home and you can be thinking about something in your conscious mind, about a project you're working on at work, what you want to have for dinner, something else you're thinking about. But you can be steering the car and driving home, staying in the lane of the freeway, basically on autopilot, as the saying goes. And you cannot even, when you get home, remembering, even driving home the last 5 miles. But all that is subconscious. Your subconscious mind of a human is all pattern matching. So look up everything about how pattern matching works. Because pattern matching basically, and then if you want to get into the weeds, I'll let you do more research on it. But pattern matching is picking out an object within a bigger pattern scene. And that my mind is not good at. My mind is good at the conscious mind of images in your brain. So you have the part of your brain that does the talking, of the conscious mind. So that pattern matching is all your subconscious. Your subconscious is like a blank slate here, and all your subconscious is all the things that are automatic. So once you train your subconscious, it's all just automatic. So it's like the model that's been already trained and locked in. Now it's just pattern matching, and it's going off its trained data, but it's not doing, I don't know if I know how to explain it, but it's not doing the high level thinking. So that's where it gets into the gray area of the high level conscious thinking of the human brain and how it can do some of the thinking techniques, the theory and thinking part, and why theory and thinking was such a struggle for AI researchers to get it to do. Pattern matching was easy so when you pick out, I've done a game where maybe there's a purse or there's an umbrella or there's a suitcase in a room, and you're supposed to pick out all the 5 objects. It would take me an hour to pick out even 2 or 3 of the objects. It's a fun exercise, but I can't do that. Like when we had a Easter egg hunt at my brother's house over last Easter, and one of our friends picked out 7 Easter eggs, and I picked out 2, because my brain can't do that. But what my brain can do is visualize. Visualize, 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 and come up with these visual images from past things that have seen, and making up new visual images that I haven't seen before. So I'm very good at making new products by sitting here and looking like this and just visualizing in my mind what I want the next new product to look like. Then I've got to figure out how to take that out of my mind, which I'm not quite as good at, and putting it down on a sheet of paper, on a 2D sheet of paper, because my mind wants to see it on the 2D sheet of paper in 3D already. So my mind is seeing this object in 3D space. It's not thinking it as 2D. So when I put it on a 2D sheet of paper like this, what I'm doing is I'm trying to, if I try to draw it, I'm trying to draw 2 or 3 different parts. Like I'm trying to draw the left and the top view together. And I don't think on a 2D sheet of paper you can do that. I think you have to draw the left view. Then you got to draw the top view. Then you got to draw the front view. Then you got to draw the back view, the right view, the bottom view. So all 6 different views. And my mind wants to do the left view and the top view, or the top view and the right view, or the front view and the top view together. And that it keeps screwing me up in able to draw it and get it out on a sheet of paper. So I wish I could just plug something in here and have it put on the computer in 3D space. But I can't do that. So I have to figure out how I can take my mind's view and put it out into my design software. So when you have the conscious mind is all the theorizing, the visualizing, and then you have the second half of your conscious mind, which is the words and the voice inside your head. When you're talking, you're not visualizing the concepts. You are, which actual visual pictures inside your brain. That's this side. The talking brain is this side. So you can be talking and reasoning out a project over on this side, but you're not making visual images on this side of your brain. And so my mind can sit here when I do my focus and concentration techniques. I block out this side, which is the talking side of my brain. But it takes a lot of strength and concentration techniques to block out this side of your brain. Then you get into only the visual images of this side of your brain. When you do that, you become very, very visual, and you can design products left, right, and then some. When you can block out this side of your brain. This side of your brain is very good at a managerial role, managing role, CEO's role. But if you're in the design space, you want to be in this visual context role of a brain. And that's where I like to be. And to put the whole thing together is that I see things, words, as not words, as in images. So I tie words to images. And I talked to a little bit of a person at my tennis club that was the 2008 memory champion, I think in the world, but at least in the United States. And what he did was he took a string of numbers and he broke it up in the quadrants, and he took those quadrants and placed it on an image. So he would take an image of a chair and he would image the numbers, and he wouldn't think of them as individual numbers or words. He would think of them as images. So he'd take eight numbers together, or 10, and he would place them on an image. So, and then he would go in, take another block, place them on an image of a table, an image of a fireplace, and images of a train, and images of a bucket, an image, etc., etc. And then when he thought of the image, which is out of this part of your brain, it linked the number. So the number he remembered because he tied it to the image. Now you're going to have to go back and think about that for a moment and try it out. Try it out with 6 objects around your room. Pick out a number, write it on a sheet of paper, break it in the quadrants of 6, like 6 digits, and place it on each one. Then go back and recite those images. And then when you turn over your paper so you're not looking at the original number, write down and see if you can remember those numbers. When you can do that, you'll understand what I'm talking about. So, also images, like images, we don't file things as A, B, C, D. A as in apple, B as in baker, C as in cat, D as in dog. And we do filing by the A names go here before the B names, the C names, when we're filing stuff at an office. In our brains, we file things like things together, like images together. So when I see a golden retriever, which is another thing that's on my paperwork, when I see as an example a golden retriever, that reminds me, oh, I may not get the actual image straight away of the golden retriever that I used to have growing up, or my Irish setter growing up, but it will get the sensation. So Claude Code calls it the sensation of the feeling. So you get according to Claude Code, you get the feeling way before you get the actual picture image in your brain. The picture image is slower to coming into your brain. The picture image comes in a couple of seconds later, but the feeling of having a dog, and what it feels like in your soul and in your arms and muscles, that is what comes from seeing a dog and wanting to go up and pet a dog when we're on vacation, and saying hi to a golden retriever, and then feeling that we want to be back with our golden retrievers. That feeling comes straight away. So since it's like things are put together, even those words are images, and they get somehow combined in all this, and they're like images are put together. So we do like images in clusters instead of just names that start with A clustered together. So that's the conscious mind of thinking. But agents and models, they don't have a conscious mind. They only have a pattern matching mind. Then that's similar to our subconscious. So what I do in tennis is I take the conscious mind and I have my students think about what we're doing, the toss or drop of the ball, the strike of the racket, the seeing with our eyes, the ball hitting the strings, where in relation to our body, this way, too far out front, right here, or too far behind us, or too far this way, or that way, the strike of the ball, the low to high swing, all that is the conscious thought. So we do in learning, we humans use the conscious thought to help us learn. Then we program by repetition. That sticks into our long-term memory as well. And then I'll talk about that, and then that'll be probably the end of this session. So the conscious mind is programming the subconscious mind that's then just going to take the images and the training data, and it's going to just execute it. So that's what I think. Now I put the pieces together of all the knowledge I knew over like 30 years. I finally put the pictures together, and I think that's what people in the tennis industry and others mean by muscle memory. Again, it's not muscles that are remembering. It's that subconscious mind that is controlling and telling the muscles. It's just based on the training data, the images, the training data, and just executing. It's not thinking like the conscious mind. It's not thinking it out and then hitting the shot. It's all about the training data and executing, and then because of the training data, it's telling the muscles how to fire. So the muscles are working off the subconscious mind, that's the pattern matching mind. That's exactly how it works. Now, you can, in tennis, use your conscious mind to visualize where you want to hit the ball. If you do that in combination with the pattern matching mind, that's incredible. And that's something that humans can do. And I've done it. I've done it like last week at my tennis class that I'm teaching. I've done it so I know when you've done something and you've experienced it, you know it works or you know it doesn't work because you've experienced it. It's not me saying, oh, I'm gibberish and are you going to believe me? I've experienced it, so I know 1,000% that this does work, that you can take your conscious mind, visualize before you start your ball feed for your students, and visualize. Don't even look at the court. I'm putting my head down. I'm putting the paper in front of me, blocking out the court over there, the baseline of the opposite side of the court. And I'm visually taking the image here representing my brain, and I'm visually looking through that image and deciding which student and where do I want to strike the ball feed. And then I power the ball feed to. Also, I don't physically see a ruler that's showing me how far the shot is and everything. It's 65 feet this way and that way. That's all kind of a subconscious type thing. The image, though, is in my brain. So I'm imaging, I'm talking to this student over the middle student, over the student over here. So if I want to go through this student, all the pattern matching is already programmed in my brain. So how I rotate my body to get the ball over there opposed to here, opposed to there, is all already programmed and pattern matched in my subconscious. So then I just hit the ball over there. So I consciously picture the image. Then I subconsciously, through pattern matching, just bang over there. Now I could, if someone's throwing a ball, which is also in my paperwork, that's great to watch. If someone just throws up a ball, or I see a bumblebee goes whizzing by, or I think it's a bumblebee, I'm not sure, because your eyes only see perfectly good out this way, but this way and this way only see blurs. So you know basically a blur that, okay, it's probably a car over there, but you don't know what type car, what the door handles look like or anything. You know maybe it's a truck, a sedan, a Jaguar car, but you know it's something like that, or you know it's a bee because you're getting hearing information, plus you're getting something that you know has to be flying. But you don't know if it's a bird, a bee, a wasp, or something else flying by. You just know your pattern matching subconscious just says to you, duck out of the way. So it's not saying anything in your mind because it's not your conscious mind doing it. It's just get the heck out of the way. So it's diving to the ground, but it's not thinking. And that's the bottom line. The last thing I think I want to say here is it's not thinking. We think, and what I was trying to discover is, could we make AI's brains into thinking brains like our brains, like the thinking part of our brains? could we do that? And right now in the industry, it's like the models aren't doing that. But could I come up with a model that does have the two hemispheres, does have the conscious and subconscious, instead of just having the pattern matching and the training data to feed into that pattern matching? So, and that would be true thinking. All this, if we ever get to what simulates thinking, it'll be a pattern matching simulation, but it won't be true thinking. It'll again, this is my wrap up, it'll again just be pattern matching. It may simulate very well thinking thought. And I'm trying to figure out in my own mind if in AI we talk about listening to the Moonshots podcast, nothing I say I'm getting paid for, the Moonshots podcast, and they talk about, well, the AIs are going to be so smart, they're going to be able to train other AIs. And if they're going to be able to think and train other AIs, what does that, you should sit around, like I said before in my video earlier, you should sit around with your friends or just sit around on a nice warm day out taking in the warm sun with your favorite beverage and ponder these things. What I think, I'll say this, that is the AI going to get smart enough that they're not going to be doing pattern matching anymore? That they're going to evolve themselves into a conscious mind. Now, is that possible? Do we have to build an AI from scratch based on the conscious mind concept? Or can a pattern matching brain turn into a conscious thinking mind? That I'm still debating in my own mind. And that's what you have to debate on whether that's possible. Right now, Claude Code says, well, no, that's not possible, or they're just doing pattern matching and maybe they can simulate conscious thought. But conscious thought is not going to be true conscious thought. It's only going to be simulated conscious thought. Now you got to think of this is a very well constructed simulated conscious thought to a human viewing a robot. Is that good enough? Is the Turing test of whether I can distinguish a pattern matching robot to a robot that has true conscious thought processing, does that matter? That's another thing we need to think about. Does that matter whether this robot doesn't have to think like you and I. We are trying to train these robots and have this high level complicated stuff in our models that just bog down the CPU of our computers, basically, because it's trying to make it think and talk like a human in English. And why? My thoughts are why? Why does a robot have to talk and think like a human? And the thinking to me is it's the scared factor. It's that we're so worried that these robots are going to take over the world that we wanted to make sure that they talk like a human, they walk like a human, they quack like the duck, and they don't veer off from that notion. So we try to build in all these things. Like you can lock down an iPhone or an iPad or a Mac so far down, locked down, to not leak an ounce of data out of your system, and whether it'll be 100% locked down, but this is my example. You can lock it down so far that it won't be usable anymore. It won't be fun to use anymore. You won't get any use out of it. Yes, it won't leak your data out. Yes, it'll be totally safe, but it won't be usable anywhere more. Some of the people in the computer industry have tried that. They've tried blocking out all third-party, not using Google search and using another search engine, and trying to block out both third-party cookies and first-party cookies. Just that, trying to do that, and then try to get anything done on the internet. And you'll find that it's terrible. The one other thing that happened to me is that in the locking down system, I had my OpenClaw running. I didn't want it to run under administrator mode. Bad. You shouldn't do that. So I had it running under standard user mode. But standard user mode is not part for those network administrators, are not part of the administrator group within, I'm talking about the Mac OS. So it's not part of the administrator group. So what do you think on the hellish time I had trying to get all this to even install on my computer? I battled with that until Claude Code and Gemini CLI was able to find back doors, so to speak, we call it, ways around having to go through administrative privileges. Even me typing in my code for administrator rights, give this AI or give this thing I want to run administrator privileges to be able to install it. It wants in the Mac OS, it wants to sandbox every app it puts into this thing called a sandbox. Consider this sheet of paper as a sandbox. Out here somewhere is the OS. Out here somewhere is another sandbox. But this is one sandbox, and this is its little environment. It can operate anywhere within this environment, and this environment maybe could grow bigger or smaller dynamically, called dynamic RAM adjustment. So, but it can't go out of this environment. Therefore, it has less of a chance of messing with the OS, which you don't want to do, and crashing your system, creating a virus that goes out there, and less apt to make anything go out on the internet. So that's one thing. And because it locks all that down, it locks down so much every time I want it to go out of the sandbox and give someone privilege. And if you don't give these agents a lot of privilege to your system and dedicate one computer that if they mess it up, that you can wipe it and start over, allow one computer to do that and give it lots of privileges. Just get to the point, whatever it takes for you, but get to the point that you trust it enough to give it those privileges. It is also trying to lock down the system quite a bit. So it's doing its best job at locking down the system. I have 2 system administrators that are helping to lock down the system so stuff doesn't get in or out of my router. So I only have one agent silo able to go in and out to get data from the internet. None of my other agents can get in or out of my computer, my one computer. It can't it can maybe talk to my iPad and my iPhone, but it can't get out of the router. It's blocked from getting out of the router. Oh no, you can't do that. If you want to do internet searches, you got to explain it to Silo, and you got to hand it off to Silo and let Silo do your searching. But it can't do that. Any of my 20 other agents can't do that. So I've already blocked that down. So think of that as that's already solved. If you think that's an issue, that's in my realm, has already been solved. What's the problem is that every time I tried to implement a fix, it was blocking it. The OS and Mac was blocking it. They were saying without administrator privileges, you can't install it. You can't install that fix. You can't fix the system. And then it was like, oh man, that was just pulling my hair out I'm surprised you can see that I don't have bald spots on my head from frustration until with Claude Code and Gemini, we figured finally a way around being able to install all these fixes without having to go through administrator rights. So now I can run in standard user mode without having administrator privileges. That's our back door. Now, that took maybe weeks for us to figure out of pulling my hair out. Once Claude Code and Gemini figured out the backdoor concept and locked it into their memory, then adding fixes is like, I'm flying fixes left and right. I'm throwing papers in the air of fixes. It's like beautiful. I'm using my conscious mind to figure out, well, how can I do this fix better and that fix and everything else? So that's just amazing once we got through that hurdle. So that's what OpenClaw did not fix for me. And so that's where I want to take another quick break. Testing. 1, 2, 3, test. Okay. Now, what I want to talk about is, so once I got through that section, then what I had to do was we went back to the locking up. So immediately I started my first AI chat, and it totally went in that endless loop. And it's like, I ask, went in the endless loop right away. I can't even talk to it. So that's not going to work. And what's the issue here? That took like 2 or 3 days of thinking and asking Claude Code and thinking and then I came up with a solution and learning, and I've learned so much in the last month and a half. It's incredible. With my knowledge from the last 30 years of how the human brain works and focus and concentration techniques for tennis, I've got into the learning of how now the agents work. And now what happened was that it would lock up. And what it would do was it would have a very short window of working memory. This is the working memory. Now this model is the lockdown memory, and this can do pattern matching on what the memory, all the training data. And then this is the working memory. And the only way to make a model learn is by the files, the MD files, the personality traits that I'm making a cyber human, not just a cron job bot that goes out, but a really cyber human that then I think I'll have everything already designed as the brain goes. And then all I have to do is put that brain, I'm thinking, into a robot body of some kind. And whether I want to make a simple body that just has wheels and runs around, or if I want to make it more of a robot with hands body. But all have the brain already figured out. So this is a good thing. Now, so what it does, it crashes. The only way you can make something learn is the long-term memory is not electrical impulses in the brain anymore. That's the model, and that's the thing that's locked down. What you have to do is you have to basically just create a simulation of it. So your and my simulation is the memory.md file that resides on your hard drive. And every time, so this memory, what I figured out is this short-term memory, you've got to get the AI to periodically, and this is the management part, you've got to take this, so take a second to think. You've got to take this memory, manage it as you're talking and you're figuring out things. You've got to take this memory, meaning not me because I'm the human, but the AI has to take this memory, manage it, make sure it doesn't reach 100%. When it reaches about 80%, it has to take that memory, transfer it into the memory.md file. And then it needs to wipe out this memory, and it needs to keep going on the conversation. So that's one part. The second part is the tokens. Research and read my paperwork and to understand exactly how tokens work. I think I know only a sketch of what tokens really work. I just know that somehow you have these tokens that represent letters and words, and that's how a model was built on. And then you only have certain amount of tokens. So out of a 26 billion model that's trained on, you have a subset of about 3 billion that you can work with at any given time. That's the part that can fit in a small amount of 32 gigabyte of memory. And then you got to decide what of the 26 billion a model that you want to use at any given time. And then, so you got to work out your company and what you're using your models for. I'm using mine for designing. So yours might be for, I don't know, something else. Management, trying to stock planning, making money, all that. I may have an AI does, and that helps me to plan, and it helps because I have a CEO called Hal, Hal, from the big computer of 2001 and 2010, the Space Odyssey, Hal. So I name mine all after computers and cartoon people and stuff like that. So let me take a quick swig. Once I figured out how to get the working memory problem solved to where it could transfer it to long-term memory. So you have these things. You have the instructions that you tell the agents, and you put them in different MD files. And these MD files, each file represents certain things, like identity will have different things you put in its file. You have the soul file, which is who I am and who you are. Birth files versus bootstrap files. Bootstrap is an analogy, or an example, is you turn off your computer, you turn it on, it takes a few seconds or minutes for the computer to boot up. The boot up process is basically your operating system loading into RAM, and it resides in the RAM until you turn your computer off again. So it's copying it from your SSD or your spinning hard drive, permanent storage, copying it into RAM. The bootstrap file is the same thing. When you wake up your agent, it takes a while for the agent to come online, maybe even up to almost feels like at least 1 to 5 minutes to come online, but it's loading everything in memory. Now, to simulate a person that can pull a lot of it out of its long-term memory, for agents, we don't want to put everything into the memory.md file, the long-term memory file. What we want to do is space it out between, as I'll probably say in another segment, but I wanted to make sure I covered this. The memory file, the notes file that I created, and the conversational files that also I created that I think I talk about already. I just want to, like in this part, I wanted to clarify a few things that I had kind of backwards on this. So the JSON files are your bootstrap, and for coding, like Claude Code, it basically can do a couple other coding styles, but like languages, but it basically does Swift, Python, and C++ are its main languages. And then there may be a couple of others. And C++, so that's on the coding side. So what happens is the bootstrap file will load all these. It'll load your identity and different personality files, your soul file. It'll load into memory. And it loads almost, if not all, the .md file. So from the personality ones that are .md file to your memory files that keep the agent operating without, and it's not, again, hallucinating. My agents, again, have never hallucinated. My agents have forgot everything I just told it a minute ago, and that's what I had to fix. So remember that. That's what I had to fix, is not the hallucinating. It doesn't go off on a tangent giving me answers just for the sake of giving me an answer back and doesn't know what in the heck it's doing. That's hallucination that some of the bigger LLMs by Google and ChatGPT and so forth do, and they haven't figured it out, I don't think, like I have. So what I do is I have on the Bootstrap loading all the personality trait files in, reading the complete memory.md file, which is all the truths and things. Truths are things that it has to follow. Whether it does follow it is another story, but it has to follow those, and those are called truths. And then it has a record of all the other agents, a list, in its memory.md file plus some other data. Then it uses, I think of it as how would I do it? I don't remember everything either. What I do is I look at my notes file and I prepare by reading over documents and so forth. And they can be big documents, they can be the conversational files. I can, if it's a long project, I want it to read all the length of conversation for at least a day before. So the whole day's conversation file. Now it can do it really fast, but it still takes 1 to 5 minutes for this boot up process. Once it boots up, and if it has enough physical RAM to store this information, that's the other question, whether you have the physical RAM capability in your physical computer to run all this, and why I want to upgrade to 128 gigabyte RAM storage. But that's one side. The birth side is for a brand new agent you want to add to your company. Now, there were 8 core personality files plus memory file in the core OpenClaw that came when you installed OpenClaw. And these files, remember, aren't really tied to OpenClaw. OpenClaw packaged them all together in a neat little package you could download from GitHub, and then you can press a button and install all this. But OpenClaw is just a wrapper that helps you maintain cohesion so it doesn't forget everything. It's really about forgetting stuff. And then it's into whether it thinks and can think of ideas that that the human you and me haven't thought of before, and we can converse with, like my theorist and my physics, Vicky, and my theorist theory can do. Now that's a different conversation, but the birth file is these core 8 files, and identity, soul, agents, memory, and I think 2 other ones. Now, what happens is I added different things to the birth file that I wanted it automatically to have certain thinking turned on my Gemma 4 model. That wasn't turned on initially by doing a, quote, role. And you'll learn what a role is later. And it's just think of it as a person in your organization. They are either a coder, they are a supervisor, they are a manager of a department, they're an architect, they're a physics person, they're a mechanics, like building mechanics person, etc. That's the role. But that role alone didn't turn on other traits that I wanted my AIs to have. I had to learn about those traits and figure out why my theory prototype agent that I was testing, why that just communicated with me so much better than these other agents. These other agents were nothing more than like ChatGPT talking to that, which is great, but doesn't feel humanistic. So to get that, which theory now has, I figured out over the month and a half that I worked on this, that theory was adding thinking to it. Now you can add, I just have OpenClaw do it, so I don't know exactly what he's doing. But between doing instructions and turning on these switches in the model, because on an MOB model, you have your coding model, your thinking model, all within the Gemma 4 wrapper model, and a few other models. You have like 6 or 8 different ones. And then you have other models that only have one model. It can only code. So those are ones. Then you have all your tokens and everything else. I'm going to see if I covered it in another segment, so I don't cover it here. But in this segment that I wanted to clarify things is the birth, I wanted to have thinking turned on. I wanted to have a few other things that as an agent, I wanted to have the knowledge of how to do a simple thing like taking notes. You would think when you hire an agent for a human for your company, and if you're a manager, or think if you work for a company, think about this for a second and take a swig of drink and ponder that you want them to, you think taking notes is a basic thing that you want every agent and every human to be able to do. You don't want to have to train the human to take notes. You don't want it to go off after you tell it, well, this in the meeting, I want you to do such and such. My name's John, so John, I want you to handle blah, blah, blah of this project. This is what the project is. I'm going to give you a sheet of paper maybe stating the project, and there are files on our server. But besides those files, if you didn't have note-taking and the files to look at and the conversation, then what would it do? 2 seconds later, you would ask it, well, what did we talk about in the meeting? I looked at everything in my memory, and I have no recollection of any project called such and such, Project X, and not to be confused with X Twitter, but Project Y or Project W. I have no knowledge, and it did that to me a lot. And so what I built into it was the ability to learn how to note take. And not just take the notes, but how to read back the notes every time I re-engage it and I want to talk to it about the project. It has to reboot up in memory from being on the hard drive, SSD, into memory, and then read all those files again, and then meaning the saying getting up to speed. It has to get up to speed. Every time I go away for an hour or two, come back to it and ask, what's the update? It has to get up to speed. Some of this, if you have a big enough window of RAM, not context window, which is the token part, but physical RAM, it can keep that in physical RAM. Therefore, its getting up to speed time is going to be like that if it can keep it in RAM. But if you don't have enough RAM and you call on another agent to talk to and you pull it in, then it has to offload, like the swapping file of the Macs and computers. So you would have to have it swap out to SSD, then swap back in. And it takes 1 to 5 minutes for the swapping to happen. SSDs are very fast now, but are not that fast. So you want everything to be in RAM as much as possible. That's another reason I'm getting a Mac M5 Studio Max with 128 gigabyte of RAM, is so it can be snappier to get up to speed. And then it can feel more like talking to a human. Now, how much of this talking to Claude Code and in my paperwork is documents is just pattern matching, and how much of this is thinking. But if it can respond like this, and it can that quickly, and it can appear to me to be thinking, what's really the difference, right? Do I really care? I like to go into the weeds to find out what's actually happening. But in the logic of my brain, is it gonna feel like they're actually thinking? And I believe, yes, it's gonna trick me into thinking it's a real human I'm talking to. Or, wow, this is getting 99% of what a real human would be like. And that's just amazing in itself, even if it's not true thinking the way a human. I think true thinking the way a human does it, and AI doesn't have to work that way. That's why I do my hands like this, like throwing up your hands and saying, well, all these people that say it has to work like a human does, why? That's my pause. Asking you, why? Why does it have to work that way? If it can think, if it can reason, if it can come up with conclusions that I haven't thought of and help me with my projects and help me figuring out the big things in life and allowing me to ponder those things upon doing the little things, why doesn't matter how it's done? It's nice to know how it's done for the human knowledge. I like to do that. But if it does it differently than a human, how is that a bad thing? And how is that doing it differently if it comes to the same conclusion? Like I can hang a painting on the wall with my late mom way back when I was 20, 25 years old. And she can measure it one way and I can measure it another way. My sister can stand back and just tell me it's off a millimeter and do it that way without a measuring tape. But we all get to the same conclusion and we all do it pretty much the same quickness. So does it matter that I do it a little bit differently than my mom or my sister does if we get to the same conclusion and we're doing the same thing? Or if I come up with even a better way to do it. There's no rhyme or reason why I couldn't come up with a better way to do it. Then you have it load all these files. So it's going to read all the personality profiles every time you, quote, reboot it. Not physically turning off the computer, but you go away for an hour, come back, I'll call that rebooting. So if you go out to ask another agent and then come back to the original agent, let's say my architect, and you want a product or a project update, then I call that rebooting. So rebooting, it has to reload the personality traits. It has to reload the JSON, which is the boot up process, but it doesn't have to do the birth process. The birth process is only for a brand new age birth. So the birth is a brand new agent, you want to be part of your company. So that's what I wanted to cover on this particular segment. So you have your tokens. So then I found out that, okay, I solved that problem. So now it's not crashing, or what I call crashing, from the short-term, from the working memory, putting into the long-term memory. And then it has to decide, the AI, what it needs to reside in long-term memory and what it really doesn't need to keep long-term. You know, if I ask it a certain question, does it really need to keep that long-term, or can it throw that out? Plan that you're working on, it would need to keep that. And then I found out that the token issue was it ran out of tokens so fast that it just also crashed the system. And I had a routine, a cron job, that when it crashed the system, I didn't want it to get out of the interacting between me and the agent, so I wanted it to feel more like a company. So I didn't want it to keep crashing and giving me error messages, and just trying to give it a bigger bucket, if you will, for tokens, but still have it crash at some point in time, give me another error message, just have a bigger window before it crashes. That wasn't what I wanted. I wanted, if it gets to that point, to be able to have a cron job routine where it would reset itself. It would give me some type AI message saying, oh, let's take a break or something like that. Or I need to take a break for a minute. Something that made me feel like it was more human. So that's what I worked on, so it didn't just crash with an error message. I figure these days that, going back to my Microsoft certification days and networking, that just gave you cryptic error 475. And you had to figure out what's error 475, or like an error message in your car. I want the AI to tell me in plain English what is error 475, and never show me the actual error. Always heading off at the pass, the error message, and then researching if they need to, coming back to me and telling me, okay, we had a problem with such and such, and this quadrant of such and such memory had a problem, but in plain English. And I think that's the way AI should do it from now on. We as humans should never see the actual error message. There's no reason in heck with our current models that we should ever see an error message again. And if you want to see an error message because you're somehow that type person, go for it. But I don't want to see an error message again. I want my AIs to interpret it, to research it, to figure out a fix for it, and come back with what the error message was, and now this is the fix for it. So that's part of the issue. And so I had to spend many hours figuring out how to work in the instructions to tell the AI what to do. The truths are instructions that say these are the things that you must follow, and you can't not follow them, and you're going to get a, quote, slap on the wrist if you try to deviate from following these truths. So those are the things that I put in the memory.md file for every agent. So there's a company-wide memory.md file that gets copied over to every new agent. So if I spawn up a brand new agent, it's going to get those truths copied into their memory.md file, and those truths are ones that rarely change. I may add a truth, I may change it a little bit over time, but from day to day, those truths aren't going to change. They're going to take the same amount of memory in my MD file, memory file, and they're going to remain in there. And they're going to be read all the time to remind my robot or my agent that these are the truths, and don't not do the truths. I've had times where even Claude Code, I've told it a truth, and it didn't abide by the truth. It wasn't a big thing, but it still didn't abide by the truth. I wanted it to, every time we make a fix, I wanted to automatically write it to my Word doc file of fixes. And I didn't want to have to keep reminding it, okay, now write the fix, now write the fix, now write the fix to the file, now write the fix to the file. 70 blessed times that we did fixes, and I had to say, now write the fix to the file. I don't want to have to do that every time. I wanted to automatically do it. And I put it in as a truth. I tried different ways to explain it in its instructions, but I could not get it to, it would do it sometimes and do the file. What I wanted to do is not just write to the file. I wanted to tell me that it's writing to the file. Because how do I know it's writing to the file? And then I'll get down the road and find out, like I have, that happened to me, that it gets halfway down the plan or something, and nothing's been written to our file. So we have no record of the plan. And it's like, oh man, all the information that I can't remember isn't being written to a file that I thought was being written to a file. So for this is still my testing phase. So in my testing phase, I want you to tell me every time you're writing to the file. I trust when you're telling me you're writing to the file now. I've gotten to the point to where I know it's writing to the file. But I don't know if you don't tell me. I figure you're not writing to the file, you're not remembering it. And at least 50 or 80% of the time, it's not writing to the Word doc file. And when it says so, some of the time it won't tell me, but it will say, yes, I already updated the Word doc file. And when it tells me that, I'm pretty confident by now that it is doing what it says it's doing. But when it doesn't tell me it's doing it, that's when I have to worry that nothing's being done. So until I can rely on that it's doing it in the background, I want it to tell me every time. So it kept crashing at that. So then I had to extend the token bucket. So think of it as a bucket, and then you're expanding it. So from 3 questions I could ask it before it air out. I got it so it would do the routine and reboot itself, but it rebooted itself every 3 questions I ask, or even every 2 questions I ask, it was rebooting itself. And then after about 10 times, I said, well, that's not going to work for me. So Claude Code, expand the bucket. And I think Gemini told me I didn't have enough memory to expand the bucket. So that's why I came up with this analogy. And I stuck with the booting every 3 questions, because I thought I didn't have the room in my 32 gigabyte of memory. Then Claude Code seemed to think I did have enough room. So now it expanded to, instead of like 1,000 tokens, it went up to 20,000 tokens. Then I had to, because I like talking an hour to 2 hours on a subject. So then I had to do 20,000. Then we went up to, I think we're up to 36,000 tokens. Now that gives that's the context window. And now the context window is a very long window, but it still at some point has to reboot. And it reboots, but it also does a compacting. It compacts this window down to the last little, let's call it a paragraph, of the whole conversation. And so it goes down to a paragraph of the whole conversation and leaves that paragraph intact, but clears everything else out. So, and it compacts it down in size. And then it starts a new conversation. Now what happens when it reboots and does that, it remembers the last little bit, but doesn't remember anything prior to that. So if I'm talking about a big long plan, it can remember the last little bit to keep on track. That's how you keep an agent on track without hallucinating is one thing, but my agents don't hallucinate. They don't go off track and talk about stuff that's unrelated. That's hallucinating. And that's what like Gemini and Claude and others do. But this is just totally forgetting. And when you ask it the next day, what's our plan? And when you pull up our plan and it says, I have no recollection of the plan, then that's just totally forgetting. And you don't want to totally forget. So what did I do? Every conversation, I did a cron job, and every conversation, I made sure, and I had to do it over and over again to make sure it worked, but I got it to start a conversation file. So my whole conversation, like I'm talking to you, and all the questions, the 10, 20, 30 hour-long questions, is all in one long conversation file. Then I had to think, well, how do you, as a human, think about this for a second. How do you, as a human, remember a plan from the previous day? Now, some of you, like my brother said, I just go into a meeting and I remember everything. And to him, I kind of paused and, okay. But most people would, what? They would rely on their notes. Notes are small little pieces, jotting down just individual words, not the ands, ors, and buts, but little quick words while you're in a meeting. You take notes to remind yourself. You take notes that you have a bigger document that you can read from and where that document resides. So I have my AIs going out and reading the big documents, but I have the AIs to keep on track. I have them writing notes. So and then I have to make sure and test this and do the looping and make sure that they are taking notes. And those notes, they go back, and when they start a session, when their information gets preloaded into their working memories for the day, and they're loaded into RAM, they read all this at the beginning. That's why it takes longer to start up an agent than it is when you're talking to it. So there's maybe a 2-minute window where it has a startup process, like your OS when you turn on a computer, your boot up process. And the boot up process is that you wanted to read the memory.md file, but you wanted to read your notes.md file. And what I do is I take the notes file and I append YYY for the year, dot MM for the month, dot DD for the day. So it's going to increment the notes file. And then it's also going to do HH dot MM, and I'm visualizing this as I speak, dot SS for hours, minutes, seconds. So it can know the last 2 or 3 notes, maybe 4. It's going to pick out when it loads the next day's information in. It's going to go back to those 4, let's say, notes. And you don't want to give it too much stuff because what's going to happen is it's going to clutter its brain too much or take too long to do stuff. You still want it robust and fast. So I had to work out that opposed to thinking, long-term thinking on like a big world project, like how does the moon evolve around the sun or something, or evolve around the earth type stuff. And I don't want it to ask one question and go off for 30 minutes and then come back. So I had to figure out how to have a quick conversation, which I thought answers 90% of my questions anyway, and then have the bigger questions put off onto the thinking models. But all that is a separate issue than this that I had to figure out. So that's why now you know why it took a month and a half to get to this point. We're back to the notes files. So then they can pick up and read the notes file. And then I even have what happens though. You are working on a project, someone comes into your office, and you are taken away because they want to ask you a question, or you go off to lunch and they're asking, well, what would you like for lunch if you have it in office, or where are you going to go for lunch? And then to get back on track of your project, how do you do that? This is pause so you can think about it. Well, part of how I would do it is I would use my notes to help me. I would go back to the conversation file to help me. I would go back and read my, read my memory file, which is up here, but I would go back to my memory.md file for the agent and read that and see if that gets me back on track. Usually, so even in the conversation file, so what I do is before I leave my conversation I'm having to go off and to answer one small question, or I'm in a project and I'm not having a conversation, but I'm still in a project, and then I go off to answer one question. I have a conversation as well as the notes file, and that conversation is going to have a break point. And that break point is going to have conversation YYY.mm.dd.hours hh.mm.ss hours, minutes, seconds. And it's going to tell, so it doesn't have to read the whole file all over again. It only has to read the past place where it had to take the break. So that little paragraph with its notes file and its memory file will be able to get it back on track. And that'll help it if I break into the conversation and get it to spew off on one question. And it'll help it if it reached the context window and has to reboot. Now, the context window when it has to reboot, I found out this. it was best if I was doing a long project. I found that even if it read only the past 2 paragraphs of the conversation about the project, it was still not remembering the project. And I told it the project and everything it was supposed to work on, and it still couldn't remember it. And it was like, well, how do I handle that? So that was another like 3 days of figuring out how do I handle that. Well, I figured that on its next day, if it has a big project window it has to do, it's going to have to read back. Hopefully it saved my project the conversation already. Now, luckily it did that, and if it did that, hopefully a thumbs up if it did that. So that's the first thing. So to nail down and make sure your AIs do that without question, that you can rely on it to do that. And then when you come in the next day, it will come back to the conversation and it will read the whole conversation file and every note from yesterday, and then the full memory of your memory MD file, plus your personality files and other things. Then it will be back on track. That's basically, I think, I may have missed something, but basically I think that's where I am now. So I think my agents now are pretty darn good. I can send them out finally within the last day, maybe 2 days. I can send my data from Star Trek Architect, and it has the architect role. It has the thinking, and which is not really a role, but it has that part of the Gemini. Most of my agents are running on Gemini 4, which are the 26B model. And then I have a couple agents running on a different model. But most of mine, I think at least 5 or 10 of my agents are running on the Gemini 4. So basically, most of the Gemini 4 model is already loaded in RAM. All I have to do is load their link to it. And you can think of this as like a octopus or spider, where it has its core model and it has spider webs, spikes that go out and tie into each of the agents. So when the agent, all the agents model, which is the MD files, have to be loaded into RAM. So it takes that amount of RAM, whatever that is, but the main memory of the model itself doesn't have to be reloaded with the new model. So that takes less loading time, and also less RAM space. I figured that Gemma 4 was so good that it did most of everything I wanted all the agents to do anyway. I just tapped on, is that the word? Or appended on the role model to it. And then I got all my agents to do their own individual role, but based on the same big model. So if that makes sense, think about that for a second. Then, so the model, so what it has to do is, I get it to read all the memory file, all its notes files, and all its conversation files, whether there's one long big conversation or multiple conversations and then I say maybe for just yesterday. So yesterday and anything from this morning or today, have that read into its brains for the startup, for the boot process. then it's pretty much up to speed. It's doing pretty much, except tracking down little bits of errors here and there. It's doing a pretty good job at not losing focus. And it doesn't, none of this does, hallucinating. None of these models, like I said earlier, ever hallucinate. They don't remember things and they blank out totally because their memory hasn't been written to, but they don't hallucinate. So I fixed that. I fixed the hallucination problem. I fixed the memory not remembering problem. Then I come in and say, okay, now, what does OpenClaw do for me that I didn't spend the last month and a half having to fix myself? And I ask Claude Code. I ask maybe my agents. And I ask Gemini, Gemini chat. And then we talked about it a little bit. Oh, and I asked Data. And Data said, well, Claude Code is managing this and that I just told you for you. So you would have to manage it. You would have to manage it for yourself. Are you willing to manage it? I think Data told me this or asked me this. Are you willing to manage it yourself? Because Claude Code and Olama is managing this for you. And I told Data and I told Claude, like Claude Code, I already spent this tiring up till 3 in the morning tracing down these issues for the last month and a half to get to this point that I think works. Perfect, maybe not. So managing this from this day forward is not a big deal for me. I only have to track down little bits and pieces of errors. I don't have to do the big things anymore. I've already tackled all the big things. And so I'm saying, if I can make some OpenClaw and Olama thing out there that's super small, super fast, super efficient, built on M series and especially M5 Max, if I can, and I'm praying, I'm crossing my fingers that I get in on it before it's bought up and I have to wait 2-3 months, when I can get a M5 Max Studio with 128 gig storage and 1 terabyte of SSD, and I can use that with all this. I can, and if I can make it that it's super efficient on that M series code, this is gonna be just amazing. I'm not gonna tell you any more than that on the inner workings of how I'm planning to execute that. But if I can do that and not use Claude Code anymore, because why do I have to if I'm managing everything that Claude Code said, and everyone said the Claude Code, or not Claude Code, OpenClaw said it was managing. So, and then also OpenClaw, well, I would have to wait for their fix to come out, and their fix may not be the fix that I wanted fixed. So now I have a fix that works for me. And that's just the beauty of it. That's the beauty of having all these agents. I can build at least simple, and this is a complex project, so we'll see how it goes. So check back periodically and I'll try to give you updates and see how it goes. Because like the guy that wrote OpenClaw, I'm not doing it in a weekend. This is going to take maybe a couple weeks to maybe a month to get this finished. So I am hoping it gets finished, and I'm hoping it's as wonderful as I think it'll be, and I'm visualizing in my mind as we speak it's going to be. But it's going to be, it could be, and I know you're going to say no and want to argue with me, but it could be revolutionary. You never know. I venture to say, but we will all see when I get it, done, and I maybe in the community of GitHub or GitHub that I get someone to look at the ending code that my AIs write, to look it over and see if they verify that they did it correctly. And I will be the one that's testing all this to make sure it functions the way I want. But it's gonna be pretty amazing. So stay tuned for that. For now, if I can think, I'll put another segment in. But for now, I think that's all I really wanted to say to get you up to speed on why I haven't been doing 3D printer projects before. Because if I do this, what I'm gonna do is all my printers and everything are going to be managed by my AI robots. I'm not gonna manage them anymore. So think about that too. So for John, this is Sleeping Dog Video.